Okay, I think we got finished with everything up to that slide that says summary right there. So, to summarize everything that we talked about yesterday, if I have f of theta equals a sine times b theta plus c plus d, then I need to know how to find all of the stuff that I need to know from that equation. So, for what I'm working with here, what would my amplitude be? A. I could even, if I want, put me some absolute value bars on that A, because amplitude is always positive. You might even want to put yourself a note right here. Amplitude is always positive. Okay, the period of the function. Period is normally 2 pi, but whenever you have a horizontal expansion or compression, it's going to affect the period, so it's going to be 2 pi divided by b, because your horizontal dilation is by a factor of 1 over b, so it ends up dividing your period by b. For my phase shift, I'm just going to call it negative C. It's the opposite sign of whatever you've got for that C. Midline is going to be y equals d. And our frequency is just our reciprocal of our period, so it's going to be b divided by 2 pi. And everything we're going to do in this class is going to be in radians, so it'll always be 2 pi. You could possibly run into, in the real world somewhere, where they're using degrees instead, and basically everything stays the same except for period and frequency would have a 360 instead of a 2 pi if you were dealing with this in degrees. So if you see that somewhere else, that might become a factor. Okay, questions? This is an important one that you kind of need to have memorized, and if you do, you can answer these questions pretty quickly. So, let's put it all together and find all of these things for some different functions. Molly Adams, what's the amplitude for number 15? Very good. Connor, what is the period? It is, because you do not have a B right here, right? This X is the only thing inside the parentheses. Right, there's just an understood one there. 2 pi divided by 1 is still 2 pi, right? Oh, phase shift. None. Phase shift is the only thing you can put none for. You always have all these other things, right? But sometimes you do not have a phase shift at all. Jericho, what's my midline? Okay, specifically, we want to put y equals 4. Good. Kendall, what would the frequency be? 1 over 2 pi. 2 pi is not a fraction, but we could put it over 1, and then you just flip it to find your frequency. Okay, here? All right, let's see. Autumn, amplitude for 16. What? 1/2, perfect. Okay, Deanna, what about the period for number 16? It's still 2 pi, because we do not have a number right here in front of that X that would be a horizontal expansion or compression. Hank, what's our phase shift? It is 3. Very good. It's going to be a positive 3, or you could put right 3. Either one that you want to put there. Positive 3. Peyton, what's the midline? Very good. I love that Peyton said y equals 0 and not none. There's no vertical shift here, but you always have a midline. So if you don't have a vertical shift, it just stays at y equals 0. Okay? Michaela, what's our frequency? 1 over 2 pi again. Okay, we good there? All right, let's do a few more. Alejandro, what is our amplitude on number 17? Very good. Alyssa, what is our period on number 17? It's just pi. Because we're doing 2 pi divided by that 2 that's right here, and that just gives us pi for that. Okay, now, I'm going to skip phase shift for a second. It's a little tricky. Molly Stevens, where is the mid, even though you weren't here yesterday, do you know what the midline is going to be? Very good. It is y equals 0. And Alyssa, what is the frequency? So it's going to be the reciprocal, which means you flip the fraction. And that's not a fraction, but how could we make it a fraction? Like, how could we make pi a fraction? Any number you put it over 1, right? So we got pi over 1. So if we flip it, what will we get? 1 over pi. Good. That's a 1 on top. All right, let's go back to phase shift. What do you think the phase shift is?
Left 2.
Very good. Left 2.
You gotta drop that 2 from there.
Right. Because is this factored? It is not. And our standard form was A sine B parentheses theta plus C plus D. That is not factored. So you have to factor it to, it won't affect the period because whether you distribute the B or don't distribute the B, you get the same number. But it will mess up your phase shift if you don't factor it. So what you're having to do here is you're factoring the 2 out, and you get 2x plus 2. And so it is actually a shift to the left 2. But how many of you were thinking that it was supposed to be left 4? It looks like it's supposed to be left 4. But it has to be factored out there. Okay? Questions on that? All right. Reese, what's our amplitude on 18? Very good. And once again, very good that Reese did not say none or 0. There is no number up here. That just means it's not stretched out or squished down. So it's like it normally is, and it always has an amplitude of 1. So we've got an amplitude of 1. Let's see. Aiden, what would my period of this function be? 2 pi. It's divided by 3. Very good. Okay. Chandler, what's the phase shift going to be? Almost. It's not going to be 3. Right, 2. Because you've got to factor the 3 out there, so it's 3x minus 2 is what you're looking at there, so it should be to the right 2. So if you see it presented like this and it's not factored, you have to factor it. If it's already factored, then you'll know what it's supposed to be. Let's see. Mason, what's my midline? Good. And let's see. Lewis, what is the frequency? Very good. Okay, questions? I think these problems are easier than when they ask you to write the equation. Because if they give you the equation, you're just, as long as you know the formula for what you're supposed to get, it's just calculating, right? The more difficult problems ask you to write the equation. And some of them, like the one I gave you on the warm-up, was not too terrible. Some of them can get really tricky. Although I don't know if I gave you one. I got a couple here coming up that are a little trickier. So for 19, amplitude and midline are super easy to do. Because in your equation, you got y equals a, either sine or cosine, b theta plus c plus d. In this, A and D are just pretty straightforward. You just plug those numbers in. So like if I'm doing number 19, I know that I'm going to have y or f of x equals, I'm going to have a 4 right here in front of my sign. And then I'm going to have some stuff inside of the parentheses probably. And I'm going to have a plus 0 on the end. You don't have to write a plus 0, right? So midline is 0. If the period is 2 pi, what is my b? It's just 1 right there. In fact, let me write everything here.
You have to, like, I guess you don't have to.
You don't have to put it there. And then so phase shift of -2, I'm going to have either x or theta. I think I'll use a theta. And then what should I have inside of these parentheses? Plus 2. Now, I have some unnecessary things here that are generally not going to be written. It will probably be written this way, 4 sine. I don't really need that 1 because if I distribute it, I just get theta plus 2, and I don't really have to have that 0 on the end.
Are theta and x interchangeable?
Yeah. A lot of times they'll use theta because it's an angle, and they typically like to use theta. You don't have to use theta as a variable for an angle. It's just common for it to be used for an angle. But a lot of times they might use x. I mean, they could use t. They could use any different variable. Yeah. Okay. 20. We've got an amplitude of 0.5. So I'm going to put 0.5 out here. I'll have sine of, I'm not going to mess with the parentheses just yet. I've got a midline of 7, so I need to put a plus 7 on the outside. So those two pieces are pretty easy to come by. I have a period of pi. So my period is normally 2 pi. What number am I going to have for my b out here? I'm going to have a 2. And then I've got a phase shift of 1. So in the parentheses, I need x minus 1 for that. But make sure you got an extra set of parentheses around your x minus 1. Yes? Yes, you could. And there's a chance, like on a multiple choice problem, they might have that as an answer choice, but they won't have both at the same time. Okay, questions? All right, let's do a couple that are a little trickier. Really, it's period and phase shift that are trickiest. They're the trickiest. Amplitude midline, not too bad. These ask for sine functions. They could just as easily ask for cosine functions. I think I meant to change those for some of these to be cosine, but it does not change how you do the problem at all if it's sine versus cosine. Now, it will change what your graphs look like a little bit, but it doesn't change how you do these parts. So, f of x equals, amplitude is 5, sine, I'm going to have some stuff in the parentheses, and then I'm going to have a minus 4 over here on the end. Do you guys agree with that part? Right, easy peasy for that. Now, my period is 3 pi over 5. This is not as easy as the last problem, right? First problem is super easy because we didn't even have to put a b. Second problem, a little tougher, but 2 pi divided by 2 gives you pi, so that was pretty easy too. So if I do 2 pi divided by what gives me 3 pi over 5. That one's not easy to come up with off of the top of your head, right? So what I usually do for this is I usually just set up a little equation right here. I think, oh, I got to take 2 pi. I've got to divide it by whatever the b value is right there. And it's supposed to give me 3 pi over 5. Right? And if I want to solve that for the b, then b's in the bottom right now, so I can't solve for anything while it's in the bottom. So I could multiply by b. I'd get 2 pi equals 3 pi over 5 times b. And I need to divide by 3 pi over 5. But when I divide by a fraction, dividing fractions is easy as pie. Flip second and multiply. So it's okay to just go ahead and multiply by 5 over 3 pi. Right here on both sides. It cancels out the 5s. It cancels out the 3 pi. All you got right there is the b. And you're going to get the pi's on this actually cancel. And you got 10 thirds. That is our b value. That goes right here in the parentheses. And then I'm going to have a set of parentheses right here, x minus 6 pi. Make sure you've got parentheses around that. Sometimes, so like this could be the answer choice, but sometimes they might distribute that. So another possibility is you could have f of x equals 5 sine of 10 thirds x, and they could distribute over here where you got 10 over 3 times 6 pi over 1, which will give you 60 pi over 3, which is 20 pi. So it could be minus 20 pi minus 4. So I think AP, if they're not trying to be difficult, will usually give you this answer choice. But that blue answer choice is also correct. So if you don't see it there, if it's not factored out, they may have distributed.
On the FRQ, what would happen? Like, would they just count both, or would they like be?
They usually on the FRQ are going to tell you that they want it in fact, they might even tell you, like, we're in the form a sine b parentheses x plus c plus d, and they might ask you to find a, b, c, and d. In which case, you definitely have to give it in that top form. So I think they're usually specific enough that you're going to give it in the correct form if they are going to count off for that. But these two are equivalent to each other, so unless they have asked you to find A, B, C, and D specifically, they'd accept the blue graph. Okay? All right. Last one here. This one might be the hardest of all because look at the period here. I got 80. Doesn't even have a pi, right? So we still got to do it in radians. Everything on your exam is going to be on radians, and this might show up on your exam. So let's start with the easy parts first. So let's just do, I like to get what is easy over with first. So 60 sine, I'm going to have some parentheses stuff. It's going to be more complicated over here, plus 150. All right, and if I want, I could even go ahead and put like my x plus 10 in. Really, the phase shift is not that hard if you're doing it in this form. It's that b value right there that's the hardest to find. Okay, so I've got it, and you got to be like, what kids do wrong all the time is they just take that 80 and they plug it in right there. They put 80 right there. That will be wrong almost every time. There might be one like really weird scenario. I don't even know if it would ever work for you to plug the period in there. There's a chance, but I'd have to run some numbers on that one. But you do not plug that number in there. You're going to think to yourself, I got to take 2 pi, I've got to divide it by that b, and it has to give me the correct period, which is 80. So, to do that, it's not a very easy one to like just off the top of your head know, oh, well, the answer is this, right? But we can solve that equation for the b. So if we solve that equation for the b, cannot solve for b while it's in the denominator, what do we need to do? We'll multiply to get it back up to the top. 2 pi. This one's actually even easier to solve than the other one, really, because we don't have a fraction here. We divide by 80. Divide by 80. Now, notice something about that. 2 pi over 80. That is sort of like the reciprocal of what we had. That happens, but you're going to have to reduce it. So I still just set it up this way. So pi over 40 is going to be our b. So that's what we're going to plug in right here. And so our final answer will be f of x equals 60 sine of pi over 40 x plus 10 plus 150. They might. You never know. If they do, you're going to get pi over 40 x plus 1/4 pi. They'll probably do pi over 4. So they could. I think AP typically does not, but they could. Mm-hmm.
To go about like solving b, could you just do 2 pi over whatever b to find b every time? Find a number to put in parentheses.
Let me think. 2 pi over.
I did like 2 pi over.
Yes, because if you notice, like what we're doing right here, like it ends up doing the same thing every time. You multiply by that b, right there, and then you got b times the stuff that's over here on the right, and you're dividing it every time. So 2 pi divided by the period is going to give you that number that goes there for your b. Yeah. So b, we could write that right here. B is going to be 2 pi divided by the period. Because if we set up just like a general equation where we solve that, it would work. You'd have the same steps every time.
And 2 pi over period, that works. Like, no
Yeah.
matter what. Okay.
Yeah, that'll give you your B. What I see kids get mixed up though is like they will do like if a question asks you to find the period, you'll do 2 pi over B. If you got to find B, you got to do 2 pi over the period. Sometimes you get all confused on which one's which there sometimes. So just make sure you know which way you're going on that. Okay, questions? All right, so the first thing